Greetings. So this series of vignettes is about the current status of our understanding of evolution, and it's broad brushstrokes, writ large, and there's going to be a number of different components. This first vignette is focused on evolution as fact. I'm going to try to make the point that evolution is a fact. That is to say that over the last 500 million years, over the last billion years, over the last 2 billion years, life has changed. And there is a record of that change. So that is the fact of evolution. Beautifully and importantly, there's also a theory of evolution. And theory is a compliment. It's not a pejorative term, despite what I'm about to show you. So we will talk about both of those facets. But here I want to talk about the fact of evolution. Prior to doing that, let's just watch this brief video, which is, kind of, I don't know what to say.
Let us demand that educators around America teach evolution not as fact, but as theory.
An increasing number of parents.
Well, I'm happy to talk about evolution as theory, but I'm afraid that Mike Pence maybe doesn't understand what theory means. The students at Caltech might have a hypothesis about why the food is not good at some restaurant in Pasadena, but there's no theory of that. The theory is, if we use the word properly, and I'm going to show you the words, I think Darwin said it better than anybody. If we use the words properly, a theory is a statement of honor. It's a statement about a hypothesis that has been run through the ringer and found to be successful despite our best efforts to show it to be false. So we're going to here talk about facts. And I love this quote from Poincaré, who said, "A science is built up of facts, as a house is built up of bricks, but a mere accumulation of facts is no more a science than a pile of bricks is a house." So there's the fact of evolution. And, when we think about domestication, which is one of the things that we humans have mastered, that is evolution in real time, where it is our hand that is doing the selection process. There's a very, as I mentioned or will mention in an upcoming vignette, when I think about Darwin and birds, I don't think about the Galapagos finches, I think about pigeons, because he was a pigeon fancier. And he made a remark at one point that if one showed the skulls of pigeons to a bird expert, an ornithologist, that most of them would actually think of them as being different species, when in fact they're not. And you might say the same thing. I mean, when we wander around at a dog park, you kind of can marvel at the range of weirdnesses of dogs. You could have bulldogs and chihuahuas and Great Danes and so on. They're all basically the same species. So here's what Darwin has to say about theory. In scientific investigations, it is permitted to invent any hypothesis. And if it explains various large and independent classes of facts, it rises to the rank of a well-grounded theory. And so, here I show you two hypotheses which did not survive careful scrutiny. On the left, and this is good science, it's not bad science. It's just the fact that our imaginations are rich. We come up with different ideas about the way the world is and why it is the way it is. And often those ideas, whether it's the ether or the idea that heat's a fluid called caloric, or whether it's Lamarckism shown on the right, which is that by stretching its neck, that to reach food, that's a heritable trait. Whether it's the idea on the left, the Ptolemaic hypothesis, which is that all the planets go around the Earth. All of these are rich figments of the imagination. They're creations of the imagination. And the beauty of science, we use figments of our imagination in all sorts of different contexts. For example, currently we have figments of our imagination about the origins of SARS-CoV-2. Some people's imagination says, I hypothesize that that's a zoonosis. It comes from hopping from one animal to another. But there are other people who have the imagination that maybe it came from a lab. And the beauty of science is that the goal is actually to find ways to test those conjectures, those guesses, those acts of the imagination. There's nothing wrong with an act of the imagination. What's wrong is to assert it dogmatically without proof. And so, at any rate, theory refers to a hypothesis that has stood survive scrutiny. So, and the reason I bring that up here is that we will also talk about evolution as a theory. So, here are some of the examples that I think come from physics first. Maxwell's theory of the electromagnetic field is confirmed day in and day out every day. We can understand things about it. To me, in a way, the most compelling aspect of that theory was the reconciliation of electricity and magnetism and light, phenomena that previously had been thought of as separate and distinct. But they all fall under the same roof, with the coolest aspect of that being that there's a wave equation for the electric field, which involves a velocity, and that velocity is given by 1 over the square root of mu naught epsilon naught to a magnetic and an electric quantity. But when you plug in the numbers, what Maxwell noticed is you get out the speed of light, leading to the hypothesis that light is an electromagnetic phenomenon, which has been confirmed over and over again. Newton's theory of universal gravitation, that's confirmed all the time. Although, around large masses and so on, it has to be amended. And then the kinetic theory of gases, shown on the left, the idea that pressure in a gas is due to the collisions of individual molecules, the special theory of relativity, and the theory of evolution. These are all examples of theories. And again, I'm sorry to Mr. Pence, but the upshot is that it doesn't help his case to teach evolutionist theory, because it's making the opposite point to what he wanted to make, which is he thinks of evolution as a hypothesis, but I'm sorry, he's misguided. And I would have thought that maybe the presence of the Omicron and Delta variants of SARS-CoV-2 might have given him pause if he was intellectually honest about it. So let's talk about other examples of the facts of evolution. So one of them that's very interesting is delivered up by fossils. Moby Dick is an amazing book. It's one of my top 5 books that I've read in my life. I know that sounds pretentious, but for many of us, the reason I think we don't like it is that we're assigned to read it at age 18, and at least in my case, I was hopelessly, inadequately prepared to be interested in that book. I love this chapter on the fossil whale. Beautiful language. Having already described him in most of his present habitatory and anatomical peculiarities, it now remains to magnify him in an archaeological, fossiliferous, and antediluvian point of view. Applied to any other creature than the Leviathan, to an ant or a flea, such portly terms might justly be deemed unwarrantably grandiloquent. So what I wanted to point out, this is a book written roughly at the same time as The Origin of Species. There's no conspiracy theorists hard at work to try to debunk evolution, because it's not a twinkle in anybody's eye. But the truth of the matter is that on a plantation in the south of the United States, people dug up fossils. But by far the most wonderful of all cetacean relics was the almost complete vast skeleton of an extinct monster found in the year 1842 on the plantation of Judge Cray in Alabama. The awe-stricken, credulous slaves in the vicinity took it for the bones of one of the fallen angels. The Alabama doctors declared it a huge reptile and bestowed upon it the name of Basilosaurus. But some specimen bones of it being taken across the sea to Owen, the English anatomist, it turned out that this alleged reptile was a whale, though of a departed species. A significant illustration of the fact, again and again repeated in this book, that the skeleton of the whale furnishes but little clue to the shape of his fully invested body. So, first of all, sad, sort of disgusting fact of how this fossil was found. But I think it's really remarkable that the fossil record is so full on the subject of whale ancestors. I love this story. So, it's very interesting that the southern part of the United States, it has been a rich source of whales that tell the story of evolution, fossils that tell the rich story of the evolution of whales. And I think it's especially amusing that Georgia cetus was discovered in 1983 during the construction of the nuclear power plant Vogtle in Burke County, Georgia. The find consisted of 3 individuals, all identified as belonging to the same species. 2 of the individuals were represented by isolated bones recovered separately, which included a few vertebrae, ribs, and tooth crowns. But I won't say too much about it now, but I just think it's interesting because, the same physics that runs the nuclear power plant is the physics that allows us to understand the age of the Earth and the age of fossils and so on. And science is not a smorgasbord. We don't pick and choose which parts we find convenient. So here's a number of different whale fossils found in the southern United States. And, I'm amused that even in the LA Times, as recently as, in the last year or 5 years, that there was at one of our landfills, they actually have paleontologists on the site, and there was a sperm whale fossil found in May of 2016. Just kind of amazing. So, we just, evolution is a fact. You look around and what we find is evidence over and over and over again. If you go to, if you fly to Salt Lake City and then drive north towards Wyoming, there's Fossil Lake, which has these really remarkable, beautiful fossil, one of the most rich fossil finds that we know in the world. And, the geological timescale originally, if you like, had to do with the use of fossils, index fossils, that allowed us to understand transitions between different geological periods. And again, I'm claiming that these are examples of the fact of evolution, which is that life over time has changed. And to be blunt about it, to be concrete about it, I show this elsewhere, but this more than anything should give all of us a strong sense of the reality, the fact of evolution. I'm not sure I know of a more blatant example before all of our eyes, aside from maybe the rise of antibiotic resistance, the rise of pesticide resistant plants, and so on. We live in real time evolution, and it's a fact of our lives. So let's get on with it. I have in this series of vignettes, I'm going to talk about the fact of variation, the fact of heritability, which is to say that variation is heritable. And then finally, we'll talk about the forces of evolution, one piece of which is the fact of selection.